This is the next video, and it is going to discuss the 2C elements that make up your grade. This, by far, is, I would think, one of the most important parts of your task because it proves that you actually learned something. So it affords you 3 points, not just 1, not just 2, but 3 points. And it's based on 3 rows. So let me show you what those 3 rows are. So you're going to have row 4, row 5, and row 6, and all have to deal with applying algorithms. So please understand, the biggest thing you need to know is row 6 is the most involved. But if you do a really good job in row 6, it actually accommodates 4 and 5. So if you just concentrate on making sure you have all the stuff for row 6, 4 and 5 will fall by the wayside and you'll get the points. So let's kind of go over what 2C is all about. So up here at the top, I have copied and pasted the exact wording from College Board. The 2C, whenever you are showing your algorithms, you must have them marked in an oval. And make sure that these are going to be algorithms that you developed that have either mathematical workings or logic concepts. This is what they're looking for in 2C. 2C centers around you designing a program that uses 3 interrelated algorithms within your program. So knowing this, your planning for your program really comes into play. You need to figure out the types of functions you understand best, whether they be logic or mathematical functions. Figure out a way to incorporate them into your project in order to solve your problem. Now, let's kind of go through and break down this 2C so that you can get started and have the most bang for your bucks. All right, starting with 6, because 6, I'm telling you, if you kill it on 6, you are going to pretty much have 4 and 5 flow right into it. So we're going to start with 6. And let's kind of go over understanding what the prompt really is. So we're going to capture and paste the program segment that implements the algorithm marked with an oval. We've already talked about the oval thing. This oval must represent something that is fundamental for your program to achieve the intended purpose. So in your write-up, you're going to say my fundamental program or my main algorithm, my selected algorithm, algorithm number 1 that I'm concentrating on, and then you're going to comment in your code and in your write-up what that is. So in your code, just put main algorithm, parent algorithm, child algorithm, something along that lines that really explains and draws attention to it. Then moving on, this code must be an algorithm that you developed individually on your own. Okay, that goes without saying. It must include 2 or more algorithms. So you've got to have 2 or more that feed into each other, but they can also work independently. They must integrate mathematical, so something involving calculations, or logical concepts like Boolean type things and if-else statements, that type of thing. Things that I'm quite convinced that you know how to do just based on the code.org work. Describe how each algorithm within your selected algorithms functions independently as well as in a combination. So think in terms of parent and child functions. The child functions can work on their own, but there is a need for the child functions to work together when they're being housed by the parent function. So let's take a little peek at a program. Let's see if this runs here. Okay. So in this program, you have to click on the cat in order to up your score. So now the score right now is at 1,005. And depending on the score will depend on the pet store information. So if you have enough points, you can buy a mouse. And when you do that, you also increase the multiplier. So every time that you click on the game, it's multiplied. Watch the score, how it jumps up. So by purchasing, having enough score to purchase things, then you can go ahead and do something with that part. Okay, let's go to the next screen. All right, so here's an example of that whole parent-child thing. Notice the main function, the main algorithm is called out here at the top as a comment. This is the main algorithm. Here's a child algorithm. Here's another child algorithm. So it makes it really easy for the reader of who's evaluating your project know exactly what it is that you're talking about. So they're going to name, they've put in comments that this is the main one. This is, and it's called, the function is called purchase item, or purchase, and then in parentheses they've got the item. And then the two child ones are set prices, which is right here, and set visible items, which is right here. So this parent is holding on to these two child things in order to get an overall score. And you can know that because here's the beginning of the bracket, and it goes through, here's the ending of that bracket, and it's housing the two child algorithms. All right, so row 4, you are selecting a code segment that implements an algorithm. This could be a sequencing algorithm, it could be a different kind of algorithm, but it must accomplish the purpose. So the function is accomplishing the purpose. And remember, on events are not considered a function that you created. On events are something that code.org created. So do not use that as your function, because that was not created by you. All right, so that's row 4, just selecting a function. All right, so row 5, you're going to select the code segment that implements an algorithm that uses mathematical or logical concepts, okay? And you're going to explain how the selected algorithm functions, and you're going to describe what the selected algorithm does in relation to the overall purpose of the program. I can tell you from all the teachers that I have read on the grading group that I'm in, the ones that grade create state out and out, the reason why kids usually lose the point for row 5 is because they don't do bullet 3. They can do bullets 1 and 2, but they don't do bullet 3, and you need to make sure you do bullet 3. So if you wanted to, you could actually comment out so that you know that you're doing all 3 of these bullet points as you are writing your code. And that way, when you go back to do your write-up, it makes it so much easier. All right, row 6. Row 6, your selected code segment implements algorithm that includes at least 2 or more algorithms, and at least one of the included algorithms uses mathematical or logical concepts, and it explains one of the included algorithms functions independently. So there's where that child and parent thing comes in. Now, when you go and select your code, you need to know what kind of function you are using. So I want you to be specific. In row 6, be specific as much as possible. When you describe each one of the algorithms, you need to state the name of your algorithm. So what is the name of the function? The type of algorithm, is it selection, iteration, or sequence? Explain what it does and explain how it helps the overall program. Now, I know it's been a while since we've done selection, iteration, and sequence, but we have done it. It was like one lesson that we did, but I know sometimes it doesn't stick. So let's kind of review that. What you're going to have is, for sequencing, it's like a recipe. So if I'm making a pizza, I've got the base, the tomato sauce, the cheese, and I'm going to bake it. That's the recipe. If I've got an algorithm, that means that there's going to be a choice somewhere. So I've got the base, the tomato sauce, the topping. There's where my choice is. Do you want parsley? Sure. Okay. If not, just skip it. Cheese and then bake. That would be a selection algorithm. An iteration algorithm would do the same thing as a selection, but after you select your first topping, now you go back to topping. Do you want extra cheese? Yeah. Do you want sausage on it? Do you want pepperoni on it? And you keep going through back in a circle until you get to if nots, and then you go to cheese, and then you go to bake. So those are the three specific things. So in the example, we know that here's the logic: if, else, else if. We know that we've got math because it's adding values, or it's multiplying values in the outcome. Okay, I think that's pretty much it for this video.